Haha. um, and so I want, in the same note, I want you all to take a moment and go ahead and read this section. This is the last part of this video, this last section of the video. So we're going to read this description. All right, so I'm going to go ahead and highlight what I think is important. So an individual weights of garbage, why garbage? Okay, sample size, 23 random households. That's important to note. I like that information. Okay, after Christmas, the mean is 32.7. That's important information. Okay, and standard deviation. Okay, let's highlight it further. I want to be more exact with my highlights. I don't have hair to highlights, but my sample standard deviation is 12.056. Okay, that's important. Okay, we'll test the claim. This is a claim. This is a claim. This is a claim. We're testing the claim that the population of households in the county has a mean weight that's greater than 35 pounds. Okay, boom. That's our null hypothesis. In case you haven't checked out, we're doing hypothesis testing here. And then I'm telling you, it's a level of significance of 0.05. I'm going to talk about that in a little bit. Level of significance, often denoted as as alpha, is the probability of rejecting the null hypothesis when the null hypothesis is true. Okay, in this case, 0.05 is our significance, which means there's a 5% chance of us actually rejecting the null hypothesis when there really is no difference in what we with our claim. Okay, so it's important to understand that. Okay, and I would say the context is important so that we just understand where this data is coming from. We're not just working and shifting with numbers. Okay, so take a moment and look at your SSVA. SSVA. When looking at your SSVA, your summarization, statistics, visualizations, and analysis, it's imperative that you recognize that we're dealing with a quantitative variable. Okay, we're looking at a household, which is an observation unit within this neighborhood, or just a household in this county, and we're measuring the actual weight of their garbage. Yikes! That's a quantitative variable, and so what that means is that we're going to summarize it in terms of the mean, okay, and the standard deviation. That's why we get 32.7 and 12.1, and that's what we got in our description. This is rounded, by the way. I mean, this is more exact, and this is rounded. Our min and max are as follows, and then our sample size is 23. That's what's important from our summary statistic. When it comes to visualizing this information, it's imperative that we know our various techniques: histogram, a box plot, a violin plot. You'll see that soon. But I decided to just show you a histogram. Okay. And when it comes to actually visualizing a quantitative variable, it's important to note three things. What are those three things? Shape, spread, and distribution. Okay. Shape, spread, and distribution. Okay. And so the shape tells us whether it's unimodal, bimodal. I would say this is unimodal. Spread is about the variability that we see. This is going from 10 to 60, okay? And distribution is whether it's skewed right or skewed left. I would say this is symmetric, and it's unimodal. There's only one hump, and the spread is from 10 to 60, okay? That's how I would look at that, okay? Cool stuff. I don't know what happened at 20 minutes. Woo! I'm gonna get some complaints about that, which is fine. I'll take that. Then the analysis, I would highlight that this is my test statistic. Okay, that's a test statistic. This is the corresponding p-value. This is the degrees of freedom. This is a one-tail test. So therefore we're gonna ignore this. And again, this is my mean. The most important line here is this. Okay, so with that being said, a little bit of a digression. You can go ahead and read this on your own, but at the end of the day is if you were to flip a coin once, the probability of success is 1 over 2, 0.25. Okay, 0.5, why? Yikes. When you flip it twice, if you flip the coin 2 times, the probability of you getting heads both of those times is going to be 0.5. 5 times 0.5, which gives you 0.25. Okay. It becomes unlikely. The probability shrinks of getting those 2 heads. Okay. 3 heads in a row. 1/2 times 1/2 times 1/2 gives 1/2 times 1/2 times 1/2 gives us 1/8, right? And that's essentially 0.125. Okay. Again, really, the probability of getting all heads three times it's getting smaller. Let's do it one more time. 1/2 times 1/2 times 1/2 times 1/2. So flip a coin 4 times. The probability of getting all 4 heads is going to be 1/16, which is equal to 0.625. And so the idea is that if I were to find a sample or have a sample data that the likelihood of me observing this sample data given the null hypothesis is less than 0.0625, I'll argue that's potentially unlikely, right? It's unlikely, and that's why when we have said probabilities, when we have smaller probabilities of seeing a sample given a null hypothesis, we reject it. We reject that claim. We reject that null hypothesis when we have such small probabilities. So the point of this whole quarter discussion is for you to have an idea of it's unlikely for our null hypothesis to be true based on our sample data. Okay, based on our sample data. Okay, so hopefully that kind of sticks. And so instead of using 0.065, I have a threshold. Okay, I have just a simple threshold. If it's greater than 0.1, we fail to reject, meaning that we don't have evidence to reject that claim based on our sample. But if our p-value is less than 0.1, we start to have evidence. We're going to reject the claim, we're going to reject the null hypothesis, and we start to have evidence. And so here, when it's in between 0.05 and 0.1, we have some evidence. When it's in between 0.01 and 0.05, we have fairly strong evidence. When it's in between 0.001 and 0.01, we have very strong evidence. And then when it's less than 0.001, we have extremely strong evidence. Okay? So with that being said, I'm not going to make another video. I'm going to keep going with this. What would be the population of interest? Describe the sample. Okay. That's going to be all in the theta observation unit. It's going to be all households within the county, 23 random households within the county, each one household within the county. Okay. The variable of interest is going to be the weight of the garbage. It's going to quantitative variable. I'm going fast. What is the research question? What is the statistical technique to address this research question? It's going to be what is the population mean of discarded garbage in a county greater than 35 pounds? Is one population mean hypothesis test? What is the population? What is the parameter of interest? Is going to what's the parameter of interest? What is the parameter of interest? What is the statistic used? Describe what the value is. So the parameter of interest is going to be mu, the population mean weight of garbage discarded. The statistic is going to be x bar. Okay, and x bar is going to be equal to, I think, 32.7, and which is the sample mean. Okay, and the data is random, and that's the only assumption. Okay, state the non-alternative hypothesis using symbols and words. And so using symbols looks such like this: mu, h0, mu is equal to 35, and then h1, mu is greater than 35. And so this is us providing information in the context of the problem. Okay, and then in this situation, in hypothesis testing, we have to have a rejection region. And so here I would have draw my rejection region to be, and the reason why, so this 0 is in the middle and it's positive to the right and negative to the left. And so if I'm looking at a greater than situation, my rejection region would be over here to the right because it's a greater than. If it was less than, it would be to the left. If it was not equal to, it would be to the right and to the left. Take a note of that. All right, so with that being said, the test statistic is a standardized value that calculates the sample data during a hypothesis test. So here's the equation and also the answer. Okay, here we go. We get negative 0.9049, which should be the same value that's in the, yeah, exactly, within our output. Okay, that's our test statistic. Okay, and then from there states the p-value, which is from our output, 0.8123. So what should we do to our null hypothesis based on that p-value discussion? We're going to we're going to fail to reject. We're going to fail to reject the null hypothesis. Okay. So the p-value denotes the likelihood of observing the sample mean or extreme given our hypothesis is true, which is that the population mean weight of discarded weight is equal to 35. That's what it means. My apologies. I got ahead of myself. Okay. That's what it means. But what, right at conclusion, which is what we're going to do to our null hypothesis based on the p-value, and that's going to be based on a sample size of 23 households, we decide to fail to reject the null hypothesis. That the population mean weight of discarding garbage is equal to 35, in which the p-value is equal to 0.81233. This is going to cause a type 2 error. So there's type 1 and type 2 error. Type 1 is only when you reject the null hypothesis. You can be making a type 1 error. Only when you reject the null hypothesis, indicating that you reject it, in reality, it could be true. Whereas in this situation, we're failing to reject the null hypothesis. In reality, it could be actually false. Okay, that's what makes it a type 2 error. And then how hard was that? I feel I went really fast. I went really fast. I think I might split these into two videos and take the L there. Okay, that's fine. Okay, that's fine. As we go through these classes, I'm gonna make sure that I think that I could speed up. It could be just one video, but I just put this one up too. That's fine. Ignore this side note. I'm gonna erase this. Okay. And then here, if I were you, I'd review this. This is a good review of things that I couldn't talk about in the video, but should be talked about in general when it comes to relearning your STAT 251 material. All right, thank you very much, and next video.